We will study section 5 of chapter 1 today. We're going to be looking at applications and modeling with quadratic equations. We will not cover the geometry problems or the modeling. We're going to focus on Pythagorean theorem and the height of a projected object. So in the Pythagorean theorem, remember it is a squared plus b squared equals c squared. It's only used with right triangles, and we know that the hypotenuse is the longest side of the triangle, and it is always across or opposite from the right angle. So here we see an illustration of the Pythagorean theorem, and now we have a problem that is a real-life application problem. It says a piece of property has the shape of a right triangle. The longer leg is 20 meters longer than twice the length of the shorter leg. The hypotenuse is 10 meters longer than the length of the longer leg. Find the lengths of the sides of the triangular lot. Now notice we see the word right triangle, so that's a clue that this is probably going to require the use of Pythagorean theorem. We know for sure it does when it begins speaking about legs, longer legs, shorter legs, and so forth. And that's what we're trying to find, is the lengths of the sides of this lot. So first thing you must do is read the problem. I know that sounds obvious, but it is an important step. You have to read carefully, and if that means read it more than once, please read it more than once. So notice it says we're going to need the lengths of all three sides. That will be important when we get to the end. If you only tell me what you get for a value of x, you haven't answered the question that the problem asked for. So after we read it, we have to assign a variable. Now, you will notice that this says let x equal the length of the shorter leg in meters. Here's why you want to let x equal the shorter leg. Look for comparisons in the word problem. Here's what you see. It says the longer leg is 20 meters longer than. If you see longer than, shorter than, that's a comparison. And so it's 20 meters longer than twice the length of the shorter leg. You're looking for what follows the word than, and that's going to be what you choose for x. If you look at the next sentence, it says the hypotenuse is 10 meters longer than the length of the longer leg. Now, that's also a comparison, but if you'll think about the order in which things are getting compared, the longer leg would be in the middle. You've got to compare the hypotenuse to the longer leg, but the longer leg is getting compared to the shorter leg. So we're going to start with the shorter leg as x. Therefore, when we read the sentence that compares the longer leg to the shorter leg, that's how we end up with 2x plus 20 to represent the longer leg. And then if the hypotenuse is 10 meters longer than the longer leg, obviously we have to add 10 to the 2x plus 20. And that would give us these values. Notice I now have a triangle on the screen. That is because it's very important to try to draw a diagram if you're reading it and it's something you can represent with a diagram. So if you see right triangle, you should draw a right triangle with a short leg, a long leg, and a hypotenuse. If it speaks about a rectangle, draw your and label your sides. Now that it's drawn, we're going to write the equation. Remember, it's based on Pythagorean theorem, so a squared plus b squared equals c squared, and we will substitute these values we just defined for the short leg, the long leg, and the hypotenuse into that equation. Now it's time to solve the equation. So don't forget, when you are squaring a binomial, remember we had 2x plus 20 in parentheses squared. You've got to use FOIL or use the box. That's why we have a middle term here. So it really is 2x plus 20 times 2x plus 20. Same thing occurs on this side. It would be 2x plus 30 times 2x plus 30. Now, whenever we put like terms together, we end up with this equation, x squared minus 40x minus 500. Notice when it's quadratic and there is an x squared, you want to be certain that you move all the terms to one side of the equal sign and set it equal to 0 on the other side. Now we'll factor. This factors into x minus 50 times x plus 10. You can use the AC method. Ask yourself what multiplies to give me a negative 500 but adds to give me negative 40. That's how we ended up with these values. Set each factor equal to 0 and solve. That's using the zero factor property. Remember that from section 4. Now, you could use quadratic equation formula here if you choose to. It just turns out this one factors, and if it factors, it's probably easier and quicker to solve it that way than to use quadratic equation formula. But that's your choice, your option. Now, when we solve, we get two values, either positive 50 or a negative 10. At this point, you have to think about what is it that you are trying to solve. Well, we're looking for sides in a right triangle. And this is supposed to be the shape of a figure that we're trying to come up with the length of the sides of the lot. Can remind you of some things you need to make sure you do. If you'll notice on your note sheet, there is a box, and I want you to fill in this information. If you are using the Pythagorean theorem, first of all, if no diagram is given, then what should you do? Draw one. That goes in those two blanks under number 1. Draw one, a diagram. Number 2, be sure to correctly identify what as C? The hypotenuse. Number 3, if any side of the triangle is a binomial, then don't forget to use FOIL. Remember, first, outer, inner, last. Or you could put the box. Many of you multiplied these binomials together by drawing a box that is 2 by 2, and that will give you the same results as if you use FOIL. So if you have a binomial, two terms that are being squared, make sure you multiply and don't lose that middle term. And the last thing is, don't forget to answer the question that was in the problem. In this problem, we were asked to find all three sides, not just x. So if we stopped at x equals 50, we would not have had full credit. Now, the next example is another real-life application, height of a projected object. If air resistance is neglected, the height, which they're using the value s, in feet of an object projected directly upward from an initial height of s sub 0 or s sub naught feet with initial velocity v sub 0 feet per second is given by this equation. S equals negative 16t squared plus v sub naught t plus s sub naught. Now that subscript of a 0 simply indicates this is your starting value. So it would be your starting height or your starting velocity. T is going to represent the number of seconds after the object is projected. So T is time in seconds. The coefficient of T squared, which is negative 16, is a constant based on the gravitational force of Earth. If you're working on something in feet per second squared, you're going to have that negative 16 in your equation. This constant varies on other surfaces such as the moon and others. Now, if this projectile is launched vertically upward from the ground, the initial velocity is 100 feet per second. Neglecting air resistance, we're not going to worry about air resistance for this problem, then the equation that goes with this is s equals a negative 16t squared plus 100t. The question is, after how many seconds would it be 50 feet above the ground? So we need to ask ourselves, if you look at the box, we've got two variables in this problem. We have s and we have t. Which one do we need to find? Well, the question says, after how many seconds will it be 50 feet above the ground? We're looking for t. So in that first blank in the box, you need to put t. We need to find t. And we were given the s, or the height, in the problem. So that means plug in 50 for which letter? S. Then we'll set the equation equal to what? 0, and then we can solve it. So we plugged in 50 for the s. Because I see a t squared in the problem, I need to get everything on one side, set it equal to 0, put it in standard form, and now I can solve. Again, your option is you can either factor it if it's something you think would factor easily, or you can use the quadratic equation formula. Now, since these all had a common factor of -2, you could think of it as factoring out a -2. That's going to reduce down what would be in the parentheses to 8t squared minus 50t plus 20. So after how many seconds would it be 50 feet above the ground? That looks like that might not be as easy to factor. If you use the quadratic formula, then you can plug in, and this is what it will look like. Another thing to consider when we're speaking about looking for time for this projected height, the odds are pretty good you're going to end up with a decimal value because we have fractions of a second. You can think about what happens when you shoot something into the air. If you're timing when it comes back to the earth, the odds aren't really good it's going to land exactly at an integer value for time. So usually these you will want to use the quadratic formula. Don't forget the plus or minus. We plug in, and then we're going to simplify. Always start with that discriminant, the part underneath the radical, and simplify there first. We get 1700 for a value, which is the number we'll have to take the square root of, and that's going to give us two possible values for t. Either t is 0.55 or t is about 5.70, and this is in seconds. Now you might be wondering, why am I getting two answers? Think about it. You're projecting something in the air from the ground, and if the question is when would it be 50 feet above the ground, it happens one time on the way up, but it will happen again on the way down. So the first value, the smallest one, is on the way up when it hits 50, and the second down. Okay? So if they ask you this question, you would provide both answers. Now, a second type of question you might be asked regarding projectile height is how long would it take for the projectile to return to the ground? Think about it. Because of gravity, anything you shoot into the air is going to come back to the ground. And when it's on the ground, what would be its height above the ground? 0 feet. So what that means is we're going to want to put 0 where? For s. So in your box, what is the height when it returns to the ground? 0. Plug in that value for the letter s. All right, so this is what our equation would look like here. Now, this one, again, you've got options. We can try to factor, or we can go to the quadratic formula. This one does factor pretty easily. So we can factor it out to be a -4t times 4t minus 25. Set each of those factors equal to 0, and we do get two different values for t. The first one is 0, but think about it, that would be the value or the time before it shot off. Okay, at 0 seconds it's still on the ground. Then it goes up in the air. When it comes back to the ground, it's 6.25 seconds later. So if it's asking when would it return to the ground, the only answer we choose from these is 6.25 seconds. Okay?